That's clear. Hi, everybody. I should introduce myself. My name is Mark Heslop. I'm the International Maths Subject Partner here at Pearson. So I'm a former teacher. I spent 15 years in the classroom. Basically, it's my job to give you the insights from the exams, deliver training for you, and just field any queries that you might have around the specification. So I'm going to go ahead and just fire up the agenda for today. I'm going to do some notices because I'm getting some common themes to questions about our new modular International GCSE specification. I'm going to go through some insights from the foundation tier. I'm going to spend more time on the higher tier because we do get a lot more entries around the world than the foundation tier, but there are some interesting lessons from the foundation tier. We're going to look at tiering guidance on how to help you make that decision between foundation and higher tier, because I'm aware that international teachers are under a lot of pressure to enter everyone for the higher tier, and it may not be the best thing for their students. And we're going to have a quick look at some resources you can use to support the course. So for those of you who may not be aware, we have our new International GCSE modular version of the linear specification. No change in the content. We just have defined content between paper 1 and paper 2. And I'm getting a lot of questions around the world of how people can use the entry window. So I thought I'd just share with you the kind of queries that I'm getting. So question I often get asked is, can I use the modular papers if I still want to teach linearly? So I get centres telling me that they feel that a linear teaching method is the most appropriate for their students, but can they use the modular papers at the end of the 2 years for that defined content per paper to make the revision more manageable, help keep their students' stress levels down? And the answer is absolutely yes, you can. So you can enter both the papers in summer of next year. And then the option that the course was designed around, which was to have the first unit in the summer of year 10, potentially a reset option in the autumn term, and then the second unit in the end of year 11. But I also get centres saying, I don't think my students would be ready. They're not mature enough at the end of year 10 in my centre. Can I alter in the autumn term? Yeah, you could alter, for instance, the first unit in the autumn term of year 11 and the second unit in the summer of year 11. I also think there's some reset advantages that's worthwhile just teasing out, even if you're on a linear entry pattern. So if you've taken the linear exams, if your student wants to improve their grade in the sixth form, they've got to retake both the papers in one series. But if they've taken the modular papers, they could resit one paper at a time, giving them sort of less distraction for their further study. So it's worthwhile considering. And then in terms of tiering, so I'm aware that there's probably a higher percentage of grade 3s on the higher tier than there should be. I think that's possibly students who should have been entered for the foundation tier, but because of a lot of parental pressure, they're entered from the higher tier, and they might have been able to get a better grade on the foundation tier. What you could do is enter students on the higher tier unit 1 in the summer of year 10. And if they don't do very well, you could enter them on for the foundation tier in the autumn of year 11. Now, to cash in, they've got to have taken both either both the foundation or the higher tier papers. You can't cash in a foundation and a higher tier. That's a forbidden combination. But from the result of that, you could then decide whether to finish off the foundation unit 2 or the higher unit 2 in the summer of year 11. And the alternative is, I'm aware that there's centres around the world that have dedicated foundation tier classes. So if you have students who at the end of year 10 on foundation tier have done really, really well. If you see me looking left, by the way, it's because I've got this on a separate screen. They've done really, really well in the foundation tier, and I'm going to do some tiering guidance later on. You could get them through the additional material for the first unit of the higher tier in the autumn of year 11 and try them, see how they get on the higher tier content for the first unit, and then use that to make a more informed decision about whether to finish off the foundation tier or the higher tier at the end of year 11. So I think the modular approach, same content as linear, gives you a bit more flexibility and a bit more of an insight into tiering. Well, let's crack on with the foundation tier. Now, I spend a lot of time every year looking at the performance data, the examiner's reports, the mark schemes and the questions, and just pulling it all together as something more coherent. Now, the next slide There's quite a lot of numbers on it. Don't worry about the numbers. What I have here is question by question, the average mark or the average performance at each grade on each question. And I've highlighted the top 10 performing questions and the bottom 10 performing questions. So this is Foundation 2, Unit 1, and this is Foundation 2, Unit 2. Now, what strikes me this year is that the first third of the paper should really be the solid marks for your Foundation tier students. I'm going to show you what the higher tier looks like. So this is the higher tier, where they're absolutely getting those marks at the start of the paper. And I think the message from this is that the first part of the paper is absolutely key to students. And what we're seeing is students not performing as well on those questions as they probably should do. And it's worthwhile not underestimating that students should be engaging with those questions. And it's not that they need some support on them, it's that they just sometimes forget that they've covered a topic, but actually engaging with a question just helps them to remind them, I need to go look that up. And it's questions that they can sort out themselves. And that seems to be the key message from Foundation Tier this year. So I'm going to give you some examples. Okay, so this is question 6. So we've got write down the number of lines of symmetry. Now we know some students find that difficult. Mark the shape and mark with letter R the right angle. On the shape, mark a letter O with an obtuse angle and find by measuring the size of the angle marked with X. Now in the rest of this presentation, I'm looking for those questions that unexpectedly underperformed that we can do something about, either by just tweaking the way we teach it, tweaking the way we revise. But here's the statistics. So like I say, I'm not surprised about that A in terms of lines of symmetry. What does surprise me is D. Measure the angle marked X. Only 53% of students overall could measure that angle. Some of these statistics were so interesting, I had to go and double check them. But here's the mark scheme. I'm not going to go through many of the mark schemes, but they're there for when you get the copy of the presentation so you can look at this in your own time. But my question for you is whether you think it's a problem with students not remembering how to measure angle or whether they've actually got the right kit in the examination. Now, I get feedback from the examiners that they know too often students don't have equipment within examinations because a student will write, I couldn't measure this line or this angle because I didn't actually have a protractor or a ruler. So my question for you is, do you or your exams officer, before the start of the examination, check that the students have got their equipment? Now, I'm not going to suggest that you go into an exam hall and say, put your hands up if you're missing anything. That's going to unsettle the students. But I can, and when I was in teaching, I could get the student to put all their equipment out on the desk, and then I could check 180 pupils, just walking up and down the aisles for a quick visual check. I could check 180 pupils in about a minute. And then at that point, we've seen that there's some equipment missing, we can lend it to students without upsetting them, without unsettling them before they're going into an examination. At that point, when that's done, we can hand over to the examining team, your exams officer, to deliver the exam. Now, I will say one thing that does come through at both foundation tier and higher tier, that shape and space is an issue at foundation tier for international students, and shape and space where we deal with algebra at the higher tier. Higher tier students are very good at algebraic questions on their own, but when they're building that into shape and space questions, that's where they would benefit from more practice. Okay. So here's an algebra question, and I'm going to make an exception for that for foundation tier students. Looking at this question here, C, so find the first and fifth term of a sequence. Okay, we're actually doing slightly better on, say, part B, which is simplifying, than just a simple substitution. So the key message in here is just for students to be just engaging with this material at a wider spread, just to help remind themselves what they have forgotten is the key message. Okay, so on to paper 2 of foundation tier. Write these numbers in order of size, write these decimals in order of size. And, sometimes there are misconceptions around this one that are good to reveal. That a lot of students call this 0.37 and 0.7, and that comes out in the exam statistics. Write in figures this number, but it's actually this last one that I wanted to highlight to you. And I'm going to highlight another question. So this is question 1 from foundation paper 2. This is question 8. quite a complex question where students have got to buy various amounts of boxes of nails and bolts and work out the change to £50. There are actually quite a few skills going on in here, but here's the statistics. So here we go. Question 8, on average, students scored 92% of the marks on that one, which I think is fantastic. But here we go on D, write down the value of 3 in the number 1,324. Only 57% of students can do that. So my message is absolutely students can do some quite fantastic stuff, and we should celebrate this. But having said that, I think just getting students to engage with copies of the first third of the exam paper outside of class to just help them remember the stuff that they've just forgotten, I think is key. So the examiner said in part B, some students confuse themselves thinking when ordering decimals between decimal numbers that have 0.13 and 0.7, like it was said. Part D, place value caused problems for some students, hundredths being the most popular wrong answer. And I'll draw your attention again, but students can actually do some fairly advanced work. Likewise on question 6. So find the value of 3.4 squared, cube root of a number, write as a single power of 7. That's tricky. And then adding brackets to make the answers correct in terms of the order of operations. But it's actually this question that students struggle with, and I'm going to compare it to this adding brackets. So here are the data. So question 1A, as we can see, was one of the highest performing questions on the exam paper. So students know how to use their calculators to do that. But look at this one, 80%, no, students scored 87% of the marks on D. But on B, finding the cube root, on average, it was only 57% of pupils who could use their calculator to do that. Part C wasn't entirely surprising. That's students find that challenging, but there's no reason why students should find finding the cube root of a number on their calculator challenging. Okay, foundation tier. Quick summary of it before we move on to the higher tier. So we've got plenty of practice for homework on the first third of the paper. Check that they know how to use things like cube roots on their calculator. Ensure that they've got the correct equipment, including protractor and compass and ruler. And be aware that the answer line takes precedence. Should ensure they always write the correct answer there. So if they've done 2 solutions, whichever answer is on the answer line, the examiner will mark the solution towards that. Okay, higher tier. Again, those exam statistics. So on the first paper, we can see that there's a nice concentration of the top performing questions on there. Tends to be the middle performing questions on a paper where students sometimes drop marks they shouldn't do. Paper 2 is an interesting one. We did see, but it was mainly because it was broken down between questions 2, 3, and 4. Some underperforming questions in there. I'm going to have a quick look at some of those. And we will be looking at those questions where students miss those easy marks. My advice for you in terms of getting students to check their working is, if we say to them at the end of the exam, if you've got lots of time left, or if you've got any time left, check your mark, check your working. That's too big a task. I sometimes see, and well, I should say often see, students losing marks in the middle of the paper unexpectedly. And I would say to students, if there's an area that to go and check first, it's those questions in the middle of the paper where, and that's more manageable for them, where you might have just underestimated the difficulty of those questions or dropped some easy marks. That's where they can often pick up marks through checking. So let's go have a look at some questions. So we're going to have a look at this question 6. Let's do it from the higher tier. Here we go. Diagram shows a solid wooden cylinder. They're given some information, work out the value of H, and then they're given some information about the density of wood, and we'll give your answer in kilograms. Here's the performance statistic. So part A, students actually was one of the top performing questions on the paper. Part B, there was a big drop off in the performance. Now, one thing that the examiners did say to me is just to remind you that there are formula on the front of the formula sheet. They did say that there was an incorrect formula used for volume. Sometimes students were using the formula of a cone. Formula for a cylinder is actually on the front of the formula, is it actually in the formula sheet? So my question for you is, How often do you get the students to remember, or how often do you remind students about that formula sheet in the front? We had it last year. There was a sphere question where students were writing r squared instead of r cubed as the power. I think students just forget about it. And you can, before the start of the exam, before you hand over to the exam team, just remind your students, just be checking when you first open your paper, just a quick revision of what formula is given to you in the examinations. The interesting part on part B is that students often lost 1 mark for failing to convert it into kilograms or converting it incorrectly, or even the density had the density formula but couldn't actually rearrange the density formula. So again, it's that algebra within shape and space that is worthwhile checking. Students do get a bit lost in that question and forget to finish it off by putting it in the right units or doing a conversion. But just keep practicing those algebra within shape and space questions. There's the full mark scheme for you. I'm not going to go for the full mark scheme through the mark scheme. That's there for you to have a look in your own time. Okay, let's go for another one. And again, it's a shape and space question. I think the reason why I'm actually popping this one up is when we look at the statistics on this, I think this question is a good indicator of grade 6 or grade 7 performance. It's one that to keep an eye on. If you're using these past papers as mocks, for the grade 7, 8, and 9 students, it was in the top 10 performing parts or subparts of a paper. It wasn't for the remaining grades. The examiners did say there was some confusion at the end with finding the perimeter. So students had actually done a lot of the hard work on here and got very far through the question, but then just got lost with what they were trying to answer at the end. So my advice is, when you're practicing these shape and space questions with algebra, just remind your students, check at the end, what have I been asked to do? Okay. Moving on to something that isn't shape and space. So I've got 2 questions on the next slide here. Question 12, solve the simultaneous equations, show clear algebraic working. And question 10, find the quartiles. And I'd like you to just drop into the chat for me which question you think the students found hardest, whether it's 12 if they found 12 hardest, or 10 if they found 10 hardest. I should say that 10 is a 2 marker and 12 is a 4 marker. So let's see if you're going to drop into the chat for me. Which question do you think students found hardest here? I'll give you a second to do that. Gives me a chance to catch my breath for a second. Hopefully you've got access to the chat. Okay, I'll move on. Here's the statistics. Question 10, statistical measures. Students got 69% of the mark from that one. And yet, on an algebraic simultaneous equations, where they've got to manipulate both equations and show clear algebraic working, students on average scored 87% of the mark and was one of the best answered questions in the paper. And this comes back to my students can actually be very good at algebraic problems. Sometimes we just need to revise some of those skills we assume they know in terms of quartiles. So it was actually a very straightforward question. But even your grade 7 students are on scoring 70% of the marks on that one. And I'm going to show you a little bit more detail on the mark scheme. So here's that question again. And on the mark scheme, they've just got to identify 2 and 7 correctly. Now the examiners say they don't mind which method these students use for finding quartiles. It's absolutely fine. We're more interested in that an awareness of quartiles, because there's different areas of the world that use an n/4 method, an n+1/4 method. The examiners deliberately design the question so it doesn't matter what method you use, you should arrive at the same answers. Finding locations of quartiles for discrete data is something that statisticians around the world cannot agree on as to the best method. They all have their advantages and disadvantages. But at this level, with small data, we're more after an appreciation of what quartiles are. So that's another topic too. Please do revise with your students. Okay. Question 13, shape and space again, an interesting one. We are asking students to give a reason for each stage of your work, and I'm giving you advice here on how to help them do that. But the examiners did say a fully correct set of reasons was rarely seen, with students needing all the appropriate circle theorems and angle rules, including the underlying words in the mark scheme. So here's what they actually had to do in terms of the mark scheme. And it's worthwhile use Exam Wizard to pull examples of these together for students, groups of circle theorems questions. They need the underlying words. So for instance, a common one that students easily miss a mark is on triangles, and they say angles in a triangle are 180 degrees. Well, we need to see angles in a triangle add up to or sum to 180 degrees. And it's the mark schemes that will give you good guidance as to the minimum that we're after in terms of an explanation. Now, I always used to say to students, it's okay to lose the marks that you can do. It's not okay to lose the marks that you can't. It's okay to lose the marks you can't do. But it's not okay to lose the marks you can do, but you're not quite showing it in the right way. For instance, not quite using the right keywords in a little bit of an explanation. The other thing the examiners stressed on this one is that it is absolutely fine to work on the diagram itself. So they could work out this angle here with a calculation, label it 1, and put it down here in the working 1 with the reason. And so they can do the calculations and the working as they work themselves around the diagram. It's quite natural for students to do that, as long as they label 1, 2, 3, and 4 and give the reason for that. And that actually makes something slightly easier in here, because one of the things that they can do in terms of annotating their diagram, this is angle BOD. Well, for this angle here, we need to say reflex BOD or obtuse BOD. The examiners accept that in explanation, but that's actually slightly easier to do on the diagram by putting effectively an angle symbol here, an arc, putting a calculation, and then a reason further down. So it's more natural for students to work on the diagram, and we should encourage them to do so. So here we go, even in the mark scheme, angles to be identified either by notation or correctly positioned on the diagram. And I do see stats of students that where they say those that are working on the diagram are more liable to get the marks. Okay. Question 19. So this is a question about stationary points. Now, the examiners did say it was pleasing that see almost 40% of students getting full marks. But I'm looking through the exam statistics from this year, the main papers, last year, and I'm seeing an issue where basic differentiation questions are underperforming compared to potentially much, much harder topics. So here's the statistics. Only 52% of students got that mark. And here's the mark scheme. They can actually get to a couple of marks here or differentiating with at least 2 terms to correct, and then follow through, setting their dy by dx equal to 0. I see students struggling internationally to engage with quite basic differentiation and then being able to attack quite complicated non-routine problems. And I think if there's a topic to just check how much teaching time you've allocated to it in your scheme of work, I think it's possibly differentiation. Came through strongly on the main papers that I did a presentation on last week as well, and it came through strongly last year. Whether it's partly that students look at these questions and think, I can't get to the end of that, so I'm not going to begin and move on, or whether they're struggling with the differentiation, I'm not sure. But what I do see is students who, once they have started to do the differentiation, can invariably finish the question. And I would say that the differentiation itself, when we've got A-level and international A-level students, when we're teaching that, they tend to cope quite well with y as a function of x, but then struggle when we move on into more concrete terms of x as a function of t for displacement, velocity, and acceleration. What I see in the exam statistics for international GCSE is the other way around. So I see students being slightly more reliable at picking up the marks where we have it embedded in a real context. So x is a function of t, work out the velocity, work out the acceleration. I think it resonates with them better as a concrete situation. And it might be worthwhile just exploring, do we teach this from y as some function of x, first of all, or do we introduce this as x as a function of t, working out the velocity, establishing that link with the gradient of the line at a point, and then move on into the generality of y equals f of x. It'd be interesting to know what people's thoughts are on that one. But I think just double check in your schemes of work how much time you spend on differentiation. Okay. Back onto the shape and space again. I'm just going to check my timing, and we're doing okay for time. So this is a question on describe fully the transformation that maps A onto B. On the grid, rotate the shape 180 degrees about -10. So we're not using the origin here. And in terms of the performance, only 47% of students could describe the transformation. 3/4 of the students got 3/4 of the mark when it comes to rotating that point that's not the origin. Now, I know from looking at exam statistics that students struggle to describe a transformation that has already been given to them. And I know the examiners say sometimes describe fully the single transformation. They get students putting down several consecutive transformations. Now, I don't think that students misreading the question. I don't think that's what they think they're supposed to be doing. I think they don't know how to do it as a single transformation and just try a couple of sequential transformations to see if they can pick up some mark. I think the underlying reason is they can't describe that. But I think there's an actual barrier here in terms of translations, which should be the easiest one for them, that cause them to lose this mark. So I'm going to fire up the mark scheme. And here we go. The examiners say it must be in vector format when they're describing a transformation. And I think that's worthwhile. If you're representing your department on this call, spread that around your department, but it must be in vector format when they are describing a translation. And I think we should take away from this that students are actually pretty good at, say, rotating about a non-origin central rotation, but more practice is required on the describing of transformations where the shapes are given to them than there is practice on actually implementing a transformation that they're given. Okay. Paper 2. So, set theory. I love these set theory questions. I really enjoy them. I think we've got some barriers to students in terms of the way they're interpreting these questions. So we're asked by A union B, A prime. Harpreet states that A and B is an empty set. And then we're asked to do something quite complex at the end. I think that the statistics of that one were as they should be. Some of the others that I saw some interesting statistics. So here's the stats. Only 55% of students could list out A union B. 62% of students could work out A prime, and only 48% of students, and in that bottom 10 subparts on the paper, A and B equals 0. I think it's that students struggle to interpret these questions. They get lost in what they're doing. And a good way to practice that in class, and I have put the mark scheme up for benefit here. I think we should be, for instance, getting students to do a verbal explanation of what this means. Certainly, I see students struggling with A prime, not A, on a regular basis across papers at all grades. So actually getting them to write on there what this means. So for instance, not A union or B as an explanation might just help frame it in their minds better. Or for instance, on this one, A and B is an empty set. Just so it's translated into words before they actually attempt the question. It's something that I saw on the home papers, and I saw it again last year as well. The other one that's worthwhile that came through from the main papers, if you like, was the number of elements in a set, n, open brackets, close brackets. Students are not familiar with what that notation means. Okay. Cumulative frequency diagrams. There is something we can take away from this, that students are actually pretty good at being able to do cumulative frequency diagrams. So the examiners did say a small number of students did draw a line of best fit, a small minority drew an incorrect cumulative frequency graph, usually using the midpoints or a bar chart using the cumulative frequencies. But generally speaking, students were okay at doing the cumulative frequency diagram graph itself. What we then asked was, use your graph to find an estimate of the interquartile range. Use your graph to find an estimate of the value of W, where 25 workers spent more than W hours working from home. Now, there is a nuance to that. And then finally, a probability that the number of hours they were working was greater than 5 and less than or equal to 10. Now, in terms of the data, plotting the graph itself was one of the best answered questions on the paper. Students started to struggle on the interquartile range, and that was in, again, so we're talking interquartile range for discrete data and now for continuous data. And that was in one of the worst answered questions for your grade 9 students. And then really started to struggle here. And in some ways for part C, I'm not surprised. I think the students would have read it off at 25, but actually 25 workers spent more than W hours working from home. We actually need to count down 25 and read off at 35. So I think there's a nuance to that that explains why students found that question hard. But I think there's something else in here that you can take away from this session to highlight to your students. So use your graph. Notice that this part here does not say use your graph. Now, I would say students on this part would automatically start to draw lines up between 5 and 10 and try and read values. And if their graph was in error, start to lose marks. But this one, use your graph. This one does not say use your graph because we can extract that data from the table. And we're already told there's 60 workers. So we can just do 17 divided by 60 to work that out as a probability. Key one to actually think about with your students. If you see a keyword, use the graph, put the graph down. If you don't see it, use the graph. If you don't see a keyword, don't assume that you need to use the graph. You can do. Don't assume that you need to. And there's those highlighted questions there. I think the pleasant thing from this one is that cumulative frequency graphs was a strong topic for our grades 7 and below. It's just that the reason why it didn't come up for the 8s and 9s because there were other topics that they actually were stronger on, relatively. Okay, shape and space with algebra again. Let's have a look at the statistics. So work out the length of ED. Excuse me 1 second. And then we've got some algebra in there. And so to a degree, it's not surprising that these scores dropped off for algebra, but it was in one of the bottom 10 performing questions on the paper, and we're only in question 12 at this point. So for part B, the examiner says students should be encouraged to look at the diagram and decide whether the answer should be bigger or smaller, and consequently whether multiplying or dividing is appropriate. A fair percentage of students did this correctly, but failed to read the question properly and supplied the length of AD, so they enlarged 10 centimeters by the scale factor to work out AD, but did not work out ED. And it goes back to that issue like we had on that perimeter question of the trapezium. Get your students to just check at the end when they've maybe rushed through the algebra and the numbers, what is it that this question is actually answering? It might be that it's needed in a different unit. Just clarify what length am I actually working out here. There's the mark scheme. Like I say, I'm not going to go through that in any detail here, but you can look at that in your own time. But again, shape and space and algebra is an area of need for higher tier students. I think it's just a case of practicing algebra within those shape and space questions. 2 questions for you here. One to really celebrate, and one to not celebrate quite so much. So I think what's pleasing from this is, I mean, we've got here f of x and g of x, the fractional equation here, and we're given that fg of k equals 2, work out the value of k. That's complicated. And students actually did very well on this question, relatively compared to other questions. And then use algebra to show that 0.306 recurring is 34 over 111. These are the exam statistics. So question 17, function notation. On average, your students scored 60% of the marks. And even the grade 7 students were getting 63% of the marks on there. It does drop off. It's a good indicator between your grade 6 and your grade 7 students. But on the decimals, in terms of converting a recurring decimal to a notation to a fraction, students only scored on average 56% of the mark. And it was in one of the bottom 10 performing questions for your grade 9 students. Perhaps we've just neglected this one. We assume that they know it, Remember, it does say use algebra here, so we are testing the stages of the working, but I don't think that should have been a barrier to most students. I think that for this kind of question, in the method that is often taught to them, they naturally show the algebra. So I think it's quite telling that they scored more marks on question 17 than they did on question 18. So I'm going to get rid of 17 from the screen for a second, and we're going to zoom in on that mark scheme. So here's the mark scheme. And I'm going to highlight a couple of things. So the first method mark is for 2 correct algebraic equations involving recurring decimals that when subtracted give a whole number or terminating decimal. It's quite nice. They don't necessarily need to use full formal simultaneous equations notation of labeling 1 and 2. They can just write one above the other and put a subtraction sign in between them. Absolutely fine to do so in this case here. And I think the examiners are trying to be as generous as possible in order to give the students a fighting chance of getting the marks. And the second stage of the mark scheme was, so here we go to the not to this stage, that what they need to show is the 999x equals 306 and 306 over 999 or some equivalent. And the examiners did say on here, this question saw the full range of marks awarded, a significant number of students gained no marks, either by failing to use algebra, despite the instruction, or failing to identify 2 correct algebraic equations subtract. Of those who did, many lost the second mark by implying the division 999x equals 306 without showing the intermediate step. I think it's really important that we maybe practice these just that little bit more with our students. Okay, it was not uncommon to see values of 10x, 10x, 100x, and 1000x written down with the wrong pair of chosen for subtraction. A few students muddled the recurring decimals with statements. It's worth emphasizing to students that this question involves a question that involves proving a given statement require every step to be shown. Now, I think the stages from this come quite naturally for students. So I think it's more that they were struggling to actually do the recurring decimals than actually show their working through. Another interesting one on shape and space. So ABCD is a square. The point A has the coordinates 5 minus 5, 2. B has the coordinates 3, 5. Find an equation of L of the line that passes through B and C. Give your answer in the form of AX plus BY plus C equals 0, where A, B, and C are integers. And the stats on this one, I'll go back one, were actually quite low. But I think there's something that is worthwhile reminding students of. How often, and I know I used to fall into this trap because I found out from my A-level further mathematicians what in a vectors question once, how often do we remind students the convention that we go clockwise around a shape, A, B, C, D, as opposed to, as I found out, it was actually they had to prove something was a trapezium using the vector method. And there were so many wrong answers, I actually went back and checked the mark scheme until they figured out what was going on. They were labeling the quadrilateral in very interesting ways. So some did A, B, C, D. Some actually did diagonally A, B, C, D. And if you're ever got students who are unsure of this, quadrilateral is not necessarily the best way to do it. It's the one where they can mislabel it. Ask them to think about what the only logical way to label, say, a pentagon is or a triangle. Quadrilateral can be a bit odd, but as long as you start in one corner and effectively go clockwise, to a degree anti-clockwise, it doesn't actually matter. It's quadrilaterals that tends to catch students out. So just ask yourself this question: have I assumed they know how to label the vertices of a polygon, or when was the last time I actually discussed it with them? But the examiners did say a surprising number of mistakes were made at the beginning with the gradient AB. Some divided x values by y values, some subtracted x values from y values, many signs were lost, and there were plenty of numerical errors. This is actually the reason I wanted to show you this question. There is something that has come through this year absolutely strongly from the examiner's reports that students are struggling with gradient and equations of lines. Now, I know you're going to say, well, students do struggle with that. Students do struggle with the equations of lines. I'm going to highlight just how much they may be struggling with it on things that we actually potentially assume they already know. So this is some statistics from the main papers that I presented on last week. On the grid, draw the straight line with the equation y equals 2, x equals 6, and y equals x plus 1. And if I were to ask you, I think you'd probably say that either of these two is the harder for students to plot. There's the mark scheme, but here's the statistics. So 90% of students, which is really nice, could plot the line y equals 2. 90% of students could plot the line x equals 6, which I think is really refreshing and a step forward. But only 2/3 of pupils could actually plot the line y equals x plus 1. And I think that's quite insightful. Now, the examiners did allow follow-through from the lines that they were producing, but we know students find linear programming hard, but 81% of students could, from the lines they had drawn, identify the correct region. And I think that's exceedingly tricky. So just to highlight again, only 2/3 of pupils could actually draw the line on here. Higher tier pupils could actually draw the line on here, y equals x plus 1. I think maybe we've underestimated just a bit of revision even on some of the basic equations of lines. Just an example of a separate question. The straight line has the equation 5y plus 2x equals 7. Find the gradient of the straight line that is perpendicular to it. Now, there is quite a bit going on in here, but the examiners did say, and there's the mark scheme, this seemed like a very straightforward question for the grade at which it was targeted. However, we are now of the very strong opinion from the evidence from a great number of students that many do not actually know what the gradient is. We were very surprised that most students seem to think that a gradient is a value with an x or an equation. 2.5x, 5/2x were commonly seen as the gradient, as was an equation with a gradient 2.5. We would strongly recommend that students are taught that the gradient is a numerical term and not a number with an x attached. For this reason, many students only gain 1 mark because they want to see the gradient stated correctly as a numerical value. Please do not underestimate just that little bit, even if it's in revision, a little bit of extra time spent on gradients of lines and also obviously equations of lines can help students make progress in examinations. So as a summary from the higher tier, don't underestimate that some practice is needed on the easy topics again as homework. Recurring decimals conversion is one to just focus on, as is quartiles, discrete and continuous data quartiles. Please do remind them of that formula sheet on the paper so they're not getting powers wrong, volumes of cylinders or cones. Do they have the right equipment? We do get that comment on higher tier as well, that students didn't have the right kit for measuring angles, etc. Angle justifications, they can annotate the diagram and they must be practicing the reasons. Practice those basic differentiations and do have a think about how much time you're spending on that in your scheme of work. Algebra with shape and space is a real key one to just embed the practice of algebra into shape and space. Check that they're actually answering the actual question. Translations, they must be given as a vector. Interpreting set theory notation as words is a good way to give students access to that. And then finally, I'll say finally, equations of lines, equations of lines, equations of lines, equations of lines. And if I actually had some more space on this slide, I'd put equations of lines in there again. So that's the summary for the higher tier. I'm going to have a quick look at some of the statistics of tiering guidance. So some of you may be aware, some of you may not be aware of the last 40 marks of the foundation tier paper is the same questions that form the first 40 marks of the higher tier paper. And that's done as part of our tiering algorithm calculations to ensure that a student should, in theory, get the same grade on the foundation tier as the higher tier. So in theory, a grade 5 student on the higher tier should get a grade 5 on the foundation tier. That's not the difference being, not say that they have the same experience of the examinations and their revision is the important difference there. So I gather together every year all the statistics of how students do on those questions. This is the full breakdown. So there's the paper 1. We don't need to look at this in any detail. Here's the paper 2, but it's the summary of those. I'm interested in the totals. So here's the totals, and something quite interesting comes out of it. So Foundation tier, on the crossover questions, out of 80 marks, your average grade 5 foundation tier student scores about 55 marks or 54 marks. Your average higher tier student scores about 51 marks. And we actually get this pattern forming every year, whether it's main papers, regional papers, or the UK specification. The foundation tier students do slightly better at times on those crossover questions. And what I think it is that for your foundation tier students, those questions are the rear end of the paper, and they're the questions that their teachers are giving them plenty of practice on to help prepare them for in the run up to the examinations. Potentially this year, neglecting some of the more basic stuff that should form the core of the marks that they get. For your higher tier students, their teachers are actually focusing them on the rear of their paper and potentially neglecting a little bit of practice on those basic questions at the start. And these are their basic questions at the start. Now, we're not trying to answer if I put a grade 5 student through here, would they get a 5 on the higher tier? Because arguably they should do. What I am saying to you in the way that you can use these is, if when you're doing mock papers on, say, a foundation tier student, gets on the crossover questions somewhere in the mark range of, say, a grade 6 student would get on the higher tier, it's worthwhile considering whether this student is being limited by being entered for the foundation tier. And it may well be that they can pick up some if they were entered for the higher tier, and as long as it's not going to dent their confidence to be exposed to that harder material, they could conceivably achieve a grade 6 on the higher tier. Now, just to give you an idea of how many more marks they'd need, here's the grade boundaries. So, to get a grade 6 on the higher tier, we actually need 86 marks in total. So, if they were getting 60 marks, they need about 13 marks on each of the papers, and the remaining marks, and there's 60 more marks to go off that are not crossover questions. They'd need 13 marks across those to get a grade 6. So it's just worthwhile considering, if you've got foundation tier students, whether they could achieve a grade 6 on the higher tier. And equally, if in mock papers you've got students that are on the crossover questions getting 25 marks, ask yourself, would it be better for that student to be entered for the foundation tier, where they're going to have a more, from their ability perspective, a more positive exam experience? It will cut down their revision to be a subset of what they've learned for the higher tier. It's more efficient for them to revise. It's less stressful to revise for. And we know, in terms of a lot of students, helping them get their stress levels down is what's key for them achieving good grades. And also from the perspective of their other subjects, that actually, if we can help them get their stress level down on maths and make that revision more manageable, then perhaps that frees them up for more time to revise for their other subjects to lift their grades overall. I think it's really interesting to look at how we can use these crossover statistics to help have those rational conversations with parents about what is in the best interest of their child. If you're using the main papers for your any upcoming mocks, I've also got the same equivalent statistics for the main papers on the crossover data in terms of the statistics and the actual grade boundaries themselves. I'm not going to go through those because it's the same principle applied. And then the last section is on resources. So if you're teaching, or if you've moved on to doing a modular international GCSE, I've been through all 900 pages of the textbooks and identified that, and there's a spreadsheet here for using the linear textbooks with the modular specification. 37 out of the 50 chapters are entirely contained within Unit 1 or Unit 2. For the remaining 13, this is the spreadsheet that gives you the guide, literally question by question of these questions, but skip this one, these questions, but skip this one if you're in Unit 1, or vice versa for Unit 2. But as I say, 37 out of 50 chapters are entirely contained within, say, Unit 1 or Unit 2. And then in terms of supporting students for resits, so if you've got higher tier, especially if you've got higher tier students, we've actually got a transition website. Now, I helped develop this material when I was working in the UK team, but it is completely relevant to international students. So we effectively took all the common topics from international GCSE that were common to effectively the first year of the A level. So those ones that form that bedrock. So this these resources were actually intended as a transition resource between Key Stage 4 and Key Stage 5, just to consolidate those skills before they start in the sixth one. But you can use it as intervention resources in Year 11 or extension resources in Year 11, or even summer work or intervention resources in Year 12. So effectively what we did was we created a website with a section for each of the main topics that crosses over, things like your expressions, your quadratics, your inequalities, broke it down into more detail, and it actually recorded a video. It's actually the video from the UK textbook, A-level textbook. It's completely relevant. There's actually about, I think, 13 hours of videos on here and 121 worksheets, also 121 videos, 13 hours. Afraid it's me wittering on, where I do basically a step-by-step walkthrough of the examples. So this one's on rationalizing. And then to go along with that, there is a worksheet which has examples and then questions. So you can use this in many different ways, whether it's boosting intervention in Year 11 or crossover work or intervention in Year 12 to make sure the students have got those skills. The final one that's coming out this week is we have an enhanced QLA. So I've been aware that question level analysis forms for mock papers have been done in the past, where if there's a 2-mark question, students get red for getting 0, 1 for getting for amber, and 2 for green. I think that we need a bit more nuance with that. So I've built this one that takes into account the difficulty of the question. So 2-marker on, say, a grade 9 topic is different from a 2-marker on, say, a grade 3 topic. So the students are given a red, amber, green based on the information here, which is the performance statistics from the examinations. So you can actually see there's probably a couple in here. So there's 2 out of 3 marks in here. Oh, here we go. 2 out of 3 marks in here. 1 gets amber, 1 gets green, because students found those questions different levels of difficulty in the examinations. You put your student details in. There is a summary sheet. You can put in a target grade, and that will give you on, above, or below. There's arrows, because I'm aware teachers get told off for printing in color. And there's also a student feedback sheet. There's no macros in this, because I'm aware some systems have, IT systems are locked down to stop people using macros. But the students get the performance data, and they can tell question by question what grade range they were in for the questions that they answered. And it's just a way to help them to improve, really, and give that better indication of 4 marks on an easy question might not be as good as, say, 2 out of 3 marks on a harder question. Data for today is on the Maths Emporium. So we've got spreadsheets on there with the performance data of the questions, and that's where I built this session from, and the enhanced QLA. And we've also got upcoming training for you in terms of understanding assessment and improving outcomes for international A-level. We've got getting ready to teach the international GCSE modular course coming up, and getting ready to teach the international A-level course. Now, we've got a couple of minutes left at the end. I do hope that has been useful. I'm more than happy to field any questions, or if there's anything else you want me to show you back in here. I would like you to fill in the feedback form that you've got, and I'd like you to rate me on how well you think I've achieved that aim of having something on each slide with a question that you can take away and do something useful with it, implement it in your classroom to either change your delivery method and help improve the outcomes for your students. That's what I like to really focus these sessions on about. I could literally talk for hours on the statistics of the exams. There's a lot of things that are interesting, but I'm focused here on the information that is useful to help you improve your practice. I've just seen Musa's comment, where can I find the files? Anything that's in the presentation in terms of where there is a file to refer to, you can see we have links in here. So for instance, there's a link there. So when you get a copy of the file, Musa, you can go and find that data. And I hope that's been useful. I'm going to turn my microphone off and mute. We'll hang around for another couple of minutes, but thank you very much. Please do put any questions into the chat. And that's the end of this session. And I hope you found it useful. And I hope we'll see you again soon.